All right, so in this problem, we have problem 6 of section 2.4, and we're asked to find the derivative of this function. So this function has kind of a lot going on. We have our outermost function is the square function. And then our inner function, we have t to the third over t to the eighth plus 3. And so that's a quotient function. So we have an outer function. So we're dealing with, the main rule that we have to apply is that quotient rule, or excuse me, the chain rule. And then our inner function, when we differentiate that, we have to apply the quotient rule. So we kind of have two of those rules coming on, which is what makes this problem a little bit more complicated. So for h prime of t, I'm just going to first differentiate the outer function. And so I'm going to apply that power rule. Kind of ignoring that I have this complicated looking function on the inside. And then I have to the power of the first. And then I'm going to multiply by the derivative. And I have to be careful. I like to put dx, and you might encounter that as you go, that I make that mistake somewhere. So I like to just put the derivative with respect to x, but we are dealing with the variable t in this case. So then I have this 2 t to the third over t to the eighth plus 3 for my first term. And for my second term, I am going to need to apply the quotient rule. So I have this low t to the eighth plus 3 t high. So this is going to be 3t squared minus high. And I hope I don't run out of room. T to the eighth plus 3. Looks like we can make it work. It's not the best, but we can kind of make it work. Over t to the eighth plus 3 quantity squared. And then I'm going to continue with my h prime and simplify on the left here. So I have this 2t to the third. And oops. I forgot, this shouldn't be, this term right here is not supposed to be t to the eighth plus 3. This should be a derivative of the denominator. So if you caught that, you were catching my mistake. So we have this 8t to the seventh. And then we can distribute and combine like terms. So we have this t to the eighth plus 3. And then we have this 3t to the 10th plus 9 t squared minus 8t to the 10th all together over this t to the eighth plus 3 squared. And then it's kind of just some algebra simplifying and things like that. We can combine like terms. I definitely have a 3t minus an 8t. Those are like terms. So when I multiply 3t minus 8t, I get a 5t to the 10th plus a 9t squared. And then I have all of this over t to the eighth plus 3 to the third. And I can factor in this middle term. If I wanted the numerator factored completely, I can factor out from this binomial. I can factor out a t squared. However, that's not going to cancel with anything in the denominator. I would have a t to the eighth and a constant, but that 5 there just doesn't do anything. So I would leave it as it is, but you can, kind of, there's some variation in how your final answer might look.